Hey everyone, and welcome back. I am so pumped for this one. Today we're going deep on something that's really got me excited. One-bit large language models.
One-bit LLMs.
Yeah. Think of it like all the power of AI, but it's smaller and way faster and so much more efficient.
It's amazing. We might be looking at a whole new world for how accessible we can actually make AI.
Okay, so to help us navigate all this Aussie stuff, we've got some excerpts from a brand new research paper called
Oh yeah, I saw this one.
One-bit AI Infra, Part 1.1, Fast and Lossless Bitnet b1.58 Inference on CPUs. So yeah, this is really cutting-edge stuff. Fasten your seatbelts.
I'm ready.
Okay, so first things first, what are one-bit LLMs? And more importantly, why should we care?
Great questions.
I'm sure you've all at least heard of LLMs. You know, they're behind things like chatbots and text generators and all that cool AI stuff that we've been seeing. But the thing is, they're often huge and they need a ton of computing power. So that's where these one-bit LLMs come in.
Right. And the name one bit might sound like we're really oversimplifying things, and we are in a way, but the magic is all in how it's done. This research paper focuses on a model called bitnet b1.58. And you guessed it, it uses 1.58 bits.
1.58 bits.
Yeah. And that tiny little difference might not seem like a lot, but trust me, it's a total game changer for performance.
Okay, so walk me through this. We can run these really powerful AI models, but not on some huge server farm, but like on my phone, my laptop.
Exactly. And the secret ingredient that's going to make this possible is this new software stack called bitnet.cpp.
Bitnet.cpp. Got it. So how does it work?
Well, they designed it completely from scratch, and it's specifically made to work with these one-bit LLMs. And for their first release, they decided to focus on CPUs.
That's huge. That means this is going to be way more accessible. It's not just going to be for people with specialized hardware.
Exactly. This is for everyone with an everyday computer.
I love that. And what about the speed? Are we really talking about faster AI?
Oh, yeah. The speed comparisons in this paper are seriously impressive.
Give me some numbers. How much faster are we talking?
Okay, so picture this. On ARM CPUs, those little guys that power most of our phones and other mobile devices, it's over 5 times faster.
5 times faster than what?
Than another popular LLM software called llama.cpp.
Wow. Okay, so 5 times faster on those little chips.
But it gets even crazier. The bigger the model, the bigger the speed advantage bitnet.cpp have. As these LLMs get more and more complex, bitnet.cpp just keeps getting better and better.
So hold on, this isn't just some number on a spreadsheet, right? That's the difference between AI that feels slow and clunky and AI that feels seamless and instant. Like imagine real-time translation on your phone or an educational app that adapts to your learning style as you're using it.
It's going to be a whole new world.
It's amazing.
And it's not even just about how fast it is.
What else is there?
The energy efficiency. We're talking about saving a ton of energy.
Yeah, that really jumped out at me too. Like they found that on an Apple M2 chip, bitnet.cpp can cut down energy use by up to 70%.
70%.
That's insane.
I know. It really is. And, it's not just about, like, bragging rights or something. It's about making AI sustainable. Like, if you think about all these giant data centers running 24/7, and they're just using so much energy, we have to reduce AI's energy footprint, especially as these models are only going to get bigger and more complicated.
Brutally. So we get blazing fast AI, and we help save the planet. 2 birds, 1 stone.
Exactly.
The paper even mentioned an 82% reduction in energy use on an Intel i7 processor. Think about what that would mean for our phones.
Oh my gosh, our batteries would last forever.
I know.
Longer battery life, less strain on the power grid. And you know what else? Smaller carbon footprint. It's a win-win-win.
Okay, so now I have to ask, with all this compression and optimization going on, there's got to be a trade-off somewhere, right? Like the accuracy has to take a hit.
That's a great question. And honestly, it's one of the most impressive things about all this. Bitnet.cpp achieves something called lossless inference.
Lossless inference. Okay. ELI 5.
Okay, so imagine that you could take this giant encyclopedia and squeeze it all down into this tiny little pocket dictionary.
Right.
But you don't lose a single word. You get all the knowledge and all the accuracy. It's just in a much smaller package.
So to be clear, we're getting the same output from a one-bit LLM running on bitnet.cpp as we would from a full precision model.
Exactly.
That's incredible.
It just shows you how clever their whole approach is.
Okay, so we've established this is amazing tech, but what's next? What's the future hold for bitnet.cpp and all these one-bit LLMs?
Well, they're already working on expanding it to other platforms.
Like what?
Like mobile devices, GPUs, and even those special AI chips called NPUs.
So they're going to be everywhere.
Yeah. But it gets even cooler. They're even thinking about designing hardware and software specifically for one-bit AI at the same time.
Wow.
It's like tailoring the perfect suit. They're going to make it fit all the needs of these super efficient models.
So like chips that are specifically designed to run these 1-bit models.
Exactly. Imagine powerful AI that's in everything from smartphones to like your refrigerator.
That's mind-blowing.
It really makes you wonder what the world's going to look like in a few years, Ryan.
Seriously. But, okay, before we get too far ahead of ourselves, let's go back and talk about what we've learned about these 1-bit LLMs.
Right. So we started by talking about what they are and why their size and how efficient they are such game changers.
Huge game changers.
It's all about getting this super powerful AI into everyone's hands.
And then we learned all about this 1-bit thing.
Which is actually 1.58 bits.
Right, thanks to the bitnet b1.58 model. It's amazing how these little details make such a big difference.
Totally. And of course, we can't forget about bitnet.cpp, the software that's designed to unlock all the amazing speed and energy savings of these models. It's like a magic key that opens up a whole new world.
And we saw how much faster it is than traditional LLMs, like way faster.
Especially when those models get bigger and more complex. Bitnet.cpp really shines then.
Yeah, it's pretty amazing. And then there are the energy savings.
Up to 82% reduction in energy consumption.
Which is huge. We're talking about making AI more sustainable.
For sure. It's like the best of all worlds, right? AI that's crazy fast and helps protect the environment.
Absolutely. And we learned that smaller doesn't have to mean less accurate. Bitnet.cpp with lossless inference proves that.
Yeah, you don't have to sacrifice accuracy to get all those gains in speed and efficiency.
So it really makes you wonder, if we can get human-level reading speeds on just a single CPU right now, what's going to be possible in 5 years, 10 years?
Yeah.
With 1-bit LLMs. It's incredible.
I know. What applications are you most excited about? Like, what do you want to see happen with this tech?
Oh, man. I don't even know where to begin. Like, are we going to start seeing AI assistants on all our devices, our phones, our laptops? Are we going to see big breakthroughs in medicine and education because suddenly anyone can access this technology?
It's so exciting to think about.
It really is. This has just been a glimpse into what might be possible with 1-bit LLMs. I have so many questions now, and that's really what it's all about, right? So tell me what you're thinking. What are your predictions for the future of AI? Head over to our website or find us on social media, and let's keep talking about this because the future of AI is being written right now, and it looks pretty incredible. Until next time, keep learning and keep diving deep.